We today are going to try a different way of solving systems, and I think you're going to like this one a lot more. This is probably my favorite. This is the one that I always revert back to. Of the three, substitution, elimination, and graphing, this is my favorite, and it's a little bit quicker. Don't tell anybody, but it is a little bit faster. So this one's called elimination, and there are 4 steps that you're going to need to use when you are solving using elimination. And we're going to keep coming back to these steps. I don't have a ton of examples for you today because this is one of those things that maybe pausing, rewinding might help you out. Every single problem is pretty much the same, and you're going to follow the same steps every single time. So the first thing that you need to do, step 1, is you need to make sure the equations are lined up. So what that means is that you need to make sure that your x's, your pluses or minus, your y's, your equals, and your numbers are lined up. And that will make more sense here in a second. But you need to make sure that your equations are lined up. If they are not lined up, you're going to have to do a little bit of math or a little bit of algebra to bring and move problems around or move variables around. So make sure that your equations are lined up. After that, you are either going to add or subtract the equations, like old school elementary, stack them on top of each other. You're going to add or subtract the equations to eliminate the variable, like I'm just going to say a variable, so to eliminate a variable. Now, you don't get to pick whether you want to add or subtract. Based on how the problem is set up, will tell you whether you have to add or subtract. So again, you're not going to always add, you're not always going to subtract. It's going to depend on the problem. And you are adding and subtracting your equations to eliminate a variable. So you're going to add or subtract to get 0. Need to add, subtract to get 0. So after you've added or subtracted to get a 0, then what you're going to do is you're going to solve for the remaining variable. And this will all make sense here in a second. I understand it's kind of weird when you're writing out steps and you don't know what you're really doing. So once you've added or subtracted, one of the variables will actually go away. So after you've solved for the remaining variable, because there'll only be one left once you do the adding and subtracting, then remember we are solving a system, so you're going to either solve for x or y here. So because we're solving for a system, you're going to need to plug that answer in to solve for the other variable. And I promise you guys that this is a little bit easier than what we've been doing. I think you're gonna like this even more. You're probably gonna come find me and yell at me because this is so much easier. So let me go through a couple of examples. I've got 3 of them. Thinking about keeping these steps in mind, we're gonna take a look at this example first. So it says, what is the solution? And we have x plus y equals 7, 2x minus y equals 2. Step 1 says to make sure the equations are lined up. Here we have x's, the pluses and the minuses, that's totally fine. Y's equals numbers. So our equations are lined up. Then you need to add or subtract to eliminate a variable. So basically we're going to be adding or subtracting to get a 0. This is where you have to really take a look. You're not going to always add or you're not always going to subtract. So if I take x plus 2x, if I add, like we're literally going to like add or subtract vertically like you did back in elementary school. If I were to add these, I would get 3x. If I were to subtract these, I would get -1. I don't get a 0. So I'm not going to be able to eliminate x's. So then I take a look at my y's. And remember the numbers out in front here are 1, +1, and if I were to add +1 plus -1, is 0. So because that's 0, that means that I am going to add my system. So when you add them, and I'm not joking when I say you add them just like you did back in elementary school, x plus 2x is 3x. 1 plus negative 1 is 0. Cancels out. Don't write it. Bring down your equal sign. 7 plus 2 is 9. Look how beautiful this is, guys. Look how much easier. So we added or subtracted. Now we're going to solve for the remaining variable. So we are going to solve this equation right here for x. Divide by 3, and you get x to equal 3. Which again is great, but that's not all we're doing. Because we are solving a system, that means that our answer has to be a point. It has to be an x and y. So now we're going to take that 3 and plug it in to solve for the other variable. So you have two different equations right here that you can plug it into. It does not matter. I'm going to plug it into the top one, mainly because the bottom one has a negative sign. So I have x plus y equals 7, and I'm going to take that 3 and plug it in right here. So 3 plus y equals 7, subtract 3, and I get y to equal 4. So the solution to my system is 3, 4. Look how much easier that is, guys. Isn't that beautiful? Okay, let's take a look at another one. Maybe we only need to do 2. So here, my equations are lined up. The x's, this time we have 2 pluses, 4 y's equals numbers. So they are lined up. Now I have to determine whether I'm going to add or subtract. Basically, you're looking for the variables that have the same coefficient, the same number out in front. If I were to add the x's or subtract them, I would never get a 0. For my y's, though, if I were to add them, I'd get 8. But if I subtract them, I get 0. Now, subtracting, you do have to be a little bit more careful, especially when you're dealing with negative numbers. Like right here, if I take 2x minus negative 1x, 2 minus negative 1 is 3. Be careful. So 2 minus negative 1 is 3. 4 minus 4 is 0. Oh, I'm going to get a junky number here. I probably made a bad choice by changing this problem. Bring down your equal sign. 2 minus 3 is negative 1. I changed this problem last minute, guys, and I just made this is going to be junky. I'm sorry. So then you divide by 3. All of your answers today will be really, really, really nice, good, solid numbers. So don't think this is like what I'm going to be giving to you. So that's what I get x to be, and then you would plug it back in to get y. This is an awful example. I just wanted to show you one where you do have subtraction. So you need to make sure you are I'm not even going to plug that back in because that's going to be really, really nasty. You and I both don't want to deal with that. But you do need to just make sure you are being careful with the subtracting if you do have subtraction. I will be going over more examples tomorrow, but I want to walk through one more just because that one was really junky. So for B here, my variables, everything, my equations are all lined up. So then I have to figure out if I'm going to add or subtract and which variable am I going to get rid of. So I have 2x and negative 2x. If I were to subtract these, I would get a 4 because 2 minus negative 2 is 4. But if I were to add them, 2 plus negative 2 is 0. So that's what I want. So these ones I'm going to add. And you're going to see that I put a pretty obnoxious plus or minus sign off to the side here to help me out. Then I do 3 plus 2 is 5y equals 1 plus negative 6 is negative 5. Divide both sides by 5, and I get y to equal negative 1. Then you're going to take that negative 1 and plug it back in. So again, it does not matter where you plug it in. I'm going to plug it into the top one, mainly again because it doesn't have any negatives. So I have 2x plus 3 parentheses, I'm plugging in a negative 1 equals 1. Multiply this and I get 2x, positive 3 times a negative 1 is a negative 3. And then I just go through and solve. 2x equals 4, divide by 2, x equals 2. So my solution is 2, negative 1. Now, if you feel that you need more examples, please don't hesitate to reach out. I have a bunch more that I could put on here. I just didn't want to make this a really long video. But again, pause, rewind, take a look. Just be careful. You're not always adding. You're not always subtracting.